Welcome to the second episode of the series Algasm. In this video, we're going to be looking at the problem of finding the diameter of a tree. Let's get started. What's the diameter actually? Diameter or width of a tree, the number of nodes on the longest path between two leaves in a tree. Let's try to solve this. Take a look at this tree. Its diameter is 9 and this is its path. After seeing this picture, the solution that comes to the mind is if we somehow get the height of the left child and the right child and add these things along with 1 and this 1 is for the root, we'll get the job done. But the longest path need not always pass through the root and this can be a subtree in another tree. That's why we should not arrive at conclusions or settle on a plan of action to code by looking at the pictures given in the problem. So we should apply this algorithm on every node in the tree and at the end we'll get our solution. So there are two possible cases. One, the path passing through the root, and the second one is the path not passing to the root. Assume we have a height function which returns the height of a node given to it. The tree is a recursive data structure, so it's very easy to write recursive function. Let's name it diameter. We need the left child's height, like so. We need the right child's height, like so. And the left child's height plus the right child's height added with 1 can be the possible answer. So let's call it possible answer. Let's return it. But we need to apply this algorithm on every node. So let's call diameter on the left child, then the right child, and the another possible answer could be the maximum value of these two. So let's name it possible answer. Now we only need the maximum value of these two possible answers. So let's return the maximum of these. That's it. Let's take a look at the time complexity. The height function takes order of n time, where n is the number of nodes in a tree, and we are calling the diameter function on every node of the tree. So that's order of n. So we are calling order of n function n times. This gives the time complexity order of n square. And we are not using any extra space, so the space complexity is 1. Can we optimize it further? If we take a closer look at the function, we are unnecessarily calling the height function each time. If we somehow calculate the heights of every node and store in some table, then instead of calling the height function each time, we can retrieve the heights from the table in order of 1 time. In that way, we could have removed this n and the time complexity then becomes order of n. That's it. So the pre-calculate function takes order of n time. Now the diameter function takes order of n time. So the time complexity is order of n and the space complexity is order of n because we are using n space for the heights. Let's take a look at another solution. This is the previous code where I removed the height function calls. If you look at the first solution, we are calling the height function and the diameter function on the same node. So instead of calling the height and diameter separately, if we somehow get the height of that node just in time we need and compute the possible values without needing to call the height function or storing it somewhere, we could have even removed this n space. Let's figure out a way to fit these things in. I just added these guys because I'm unable to find a mind-blowing solution of this intelligence. They are storing the height of nodes in the stack. They're just exploiting the system stack calls. Very intelligent, right? Understand it yourself and have that feeling. And the final solution is kind of a different approach. Let's come back to the basics. Diameter or width of a tree, the number of nodes on the longest path between two leaves in a tree. So the diameter is nothing but the maximum value of left child's height plus right child's height plus 1 for the entire tree. I mean for each node. We require only the height function to arrive at a solution and keep on updating the maximum value along the way. This is the code, guys, and the time complexity is order of n and the space is order of 1. They're keeping the track of maximum value in this variable and solving the problem. That's it, guys. Thanks for watching.